Assalamualaikum warahmatullahi and welcome back to another video on mathematics for matriculation semester 1. So in the previous video we already discussed about indices and related topics to indices, for example laws of indices, index properties of indices and so on. Okay, so for today, for this video we will discuss about Surds. So I think you in the previous video I mentioned a little bit about Surds, something that relates Surds to the previous topics. That is when I talk about rational index, where rational index that is defined as, let's say we have a, the real number, and n is the positive integers. So when we have rational index, that is the index has the form of ratio or the form of fraction, so we can rewrite that index in terms of Surds. So we can rewrite, so a to the power of 1 over n can be written as a Surd n. So this is what I mentioned a little bit in the previous video. So we will go into Surds and related topics. Okay, so first thing first, as usual, we must define, or we must know what is Surds, what is the meaning of Surds. Okay, so we say that definition. Okay, so definition. Sorry. Definition. So we say that a Surd is a irrational number that has the form of a Surd n. So we have where n is positive integer and a is a real number. Okay, but a must not be a perfect number, which is not a perfect power of n. Okay, so we define Surd as a rational number. Okay, irrational number. So remember in the first video we talked about irrational number, that is a number that cannot be represented in the form of ratio. A number that cannot be represented in the form of ratio. Okay, so Surd is is supposed to be an irrational number of the form that takes the form a Surd n, where n is a positive integer and a is a real number that must not be a perfect power of n. So example of perfect power of n is 4, because 4 is 2 squared. Okay, now 27 is also a perfect power of n, because it is a perfect power of 3 cube. Okay, and so on. So this kind of number, we call it as perfect power of n. So the condition for a surd is A must not be perfect power of n. A must not be a perfect power of n, because if A is a perfect power of n, then we will not have surd anymore. Because inside here, this one is now a rational number. Because it's violate the first condition here. Irrational number of the irrational number. Okay, surd is an irrational number. Okay, so for example of surd is So example of surd is square root of 2, square root of 3, okay, square root of 3, okay, also what, cube root of 4, okay, or 4 surd 3 also can, and 5 surd 7, and so on. So this is a few examples of surds. Okay, so when we talk about surd, so we must know algebraic operation on surds that we can make use of. Okay, so now we go into algebraic operation. Sorry, I'm not very comfortable to write here. So algebraic operation. On surds. Okay, so now we have, okay, so the first one is related to addition and subtraction. So for addition and subtraction of two surds, okay, for example, so for addition and subtraction, surds of the same kind can be combined by combination and subtraction. Okay, what I mean by surd of same kind is, for example, we have this. So for example, we have 2 surd 3 plus 4 surd 3. Okay, so what I mean by surd of same kind is terms that has the same factors in term of surd. That is surd 3 and surd 3. So when we have the same kind of surd, so we can combine them using addition or subtraction. For example, we have here addition, so we can combine it as 2 plus 4 factor of surd 3, and then we have 6 surd 3. The same goes to subtraction. Okay, so when we have again 2 surd 3 and 5 set 2. Okay, in this example we don't have set of same kind, because the first term we have set 3, but the second term we have set 2, so we cannot combine this expression. Therefore we cannot combine as before. Therefore we left the expression as it is. Okay, so the second one is multiplication. Multiplication. Okay, so for multiplication, it is different from the previous one when we talk about addition and subtraction. For multiplication, it doesn't need to be set of same kind. It can be different, because what we do is, let's say we have, for general, we have, okay, I think I should use set NA plus, okay, I think for example I use square root first. So set A plus set B, it's supposed to be multiplication. Okay, so set A multiply set B is set AB. Okay, why? Because we go back to the definition, we go back to the laws of indices. One of the laws of the indices that states that, because we can convert this one as A half to the power of half multiply B to the power of half. So when we have two indices with different base but have the same index, so we can simplify it AB half. Okay. Alright. Okay, so for example, we have set 2 multiply set 3. So what we have here is, according to this definition, according to this operation, set 2 multiply 3. So 2 multiply 3 is 6. So we have set 6. Okay. Alright. Okay. Or conversely, if we have, let's say we have set 24. Okay. So we know that 24, it is a product of two numbers. There is many possible factors of 24. So I take this example. So we have 4 multiply 6. Okay, so we write the set 24 as set 4 multiply 6, and we can separate as set 4 set 6 and set 4, because 4 is perfect power of 2. Okay, so since 4 is perfect power of 2, so we can write it as 2 set 6. Okay. Alright. Okay, last operation is division. Okay, so for division, because when we understand the multiplication, division is simple. The division of two sets is simple, because it's still related to laws of the indices. Okay, so but now we don't write it in the form of indices, but we write it in the form of sets. Okay, so for this one, for division, we have, let's say we have two sets, set A over set B. So we can rewrite it as in terms of only one set. So set A over B. Set A over B. Okay. Okay, with condition that, okay, for second and third, we have the condition that A and B are positive real number. A and B are positive real number. Okay, so for example we have Surd 20 over Surd 5. Okay, so according to this rule, we can rewrite it in under one surd, that is Surd 20 over 5. And 20 over 5 we can simplify it. We can simplify it. 20 divided by 5 is 4. So Surd 4, and 4 is perfect power of 2. So we have now our answer is 2. Okay, so that is algebraic operation on surds, related to surds. Okay, so for example, okay, again we take example. We take some example that they combine all three, any of these rules. Okay, so example. So example, simplify. Simplify the following. A, we have Surd 96. Okay, so Surd 96 is okay, if you don't want to complicate, okay, I think we can use this method, which is okay, 96 2. So we have 4 8. Again we divide by 2, so we have 2 4. Again 2. Okay, we have here 1 2. Divide again by 2, we have 6. Okay, again divide by 2, we have 3. So 3 1. So we can have this prime factor. So we have 2 multiply 2 multiply, how many is 2 here? 5. 2 2 2 3. Okay, so I think because we have 5 2's, only 1 3's. Okay, so 2 multiply 2 is 4, and then 2 multiply 2 is 4. So we have here, instead of we have 2 2 2 2 2 3, we have 4 multiply 6. Okay, these 2 multiplied, we have 4. These 2 being multiplied, we have 4, and then these 2 being multiplied, we have 6. Okay, so we can separate them. Square root of 4, or Surd 4 multiply Surd 4 multiply Surd 6. And then because 4 is perfect power of 2, we can write it as 2 multiply 2 Surd 6, and 2 multiply 2 is 4 Surd 6. Okay, B, example B, we have square root of Surd 8 bracket Surd 20 plus Surd 12. Okay, so for this example, what we can do is, okay, either you want to separate 20 and 12 either you want to separate into two factors of 20 and for 20 and 12. Okay, you can also that, but I prefer to multiply set at to 20 and to 12. Okay, so what we have here is set 8 multiply set 20 plus set 8 multiply 12, set 12. So according to the rule that we have shown just now, so 8 multiply 20, so we have here 8 multiply 20 plus set 8 multiply 12. So 8 multiply 20 is, okay, I think okay, I think I make a mistake here. I think I make a mistake. Okay, so instead of we multiply, yeah, we can also multiply actually. Okay, but now because we have 8 is 4 multiply 2 and 20 is 4 multiply 5. Okay, so we can rewrite it as factors. So 8 factor of, the factors are 4 multiply 2 and 20 is 4 multiply 5 plus, okay, 8 was still same, we have 4 multiply 2, but for 12 it is 4 multiply 3. Okay, so what we have here is, 4 multiply 4 is 16. Okay, so I think because 4 and 4 are perfect power of 2, so we can simplify it. Okay, I will simplify it. For the rest of the numbers that are not perfect power of n, we left it in set, under the set. So 20 multiply 5 is 10 plus 4 set 2 multiply 3 is 6. Okay, alright, so that's a few examples of surds. Okay, so actually what is important is surd, because surds is just a rational index. It is just a rational index. Okay, so anything that related to surd, anything related to index is also applicable to index. Okay, but only one thing that are not applicable for index but applicable to surds, that is rationalizing the denominator. Okay, so rationalizing the denominator. Okay, so in order to explain about rationalizing the denominator, I will give you one example. Let's say we have example again. Okay, example, we have in bracket set 3 plus 2 close bracket and then multiply with another bracket set 3 minus 2. Okay, so what we will do is we expand the bracket. So we multiply set 3 to set 3 and negative 2, and then after that we multiply positive 2 to set 3 and negative 2. Okay, so what we do is set 3 multiply set 3. Set 3 multiply set 3 minus 2 set 3. Okay, and then plus 2 set 3 and then plus 2 multiply negative 2. plus 2 multiply negative 2. Okay, so we have here is, okay, this one is 3. Okay, and then negative 2 set 3 plus 2 set 3. So negative 2 set 3 is being cancelled out by positive 2 set 3. So what's left is negative 2 plus negative 2 multiply positive 2. So negative 4. Okay, negative 4. Okay, so 3 minus 1 is negative 1. Okay. Okay. So okay. So what we can see here is, here we have an expression involves surd and rational number. We have surd 3 plus 2 and then another bracket surd 3 minus 2. Okay, when we multiply both bracket, what will happen is there will be no more surds. There will no more surds in our answer, because the first one is, this one is being cancelled out by this one, and then surd 3 multiply surd 3. Okay, in terms of index, in terms of rational index, we can rewrite it as 3 half multiply 3 half. And according to the laws of indices, since we have both index have the same base, so we just add the indices. So 3 to the power of half plus half, and half plus half is 1. So 3 to the power of 1, but 3 to the power of 1 is 3. That's why I write here 3. Okay, so after that, okay, so if we see here, okay, so this surd is being cancelled out by this surd because both of them same but different sign. When we have different sign being made together, so they will cancel out each other. Okay, that's one surd already being cancelled out. Okay, here only rational number, so we don't care anymore. We can ignore it. But here, because both of them have the same, I think in the form of index form, have the same base being multiplied. So half plus half is 1. So 3 to the power of 1 is 3. So now we have here only rational number. Okay, and then we add up. What's left is now here is only rational number, no more irrational number in the form of sets. Okay. So from this example, okay, this bracket we call it as conjugate. Okay, so surd 3 minus 2 is conjugate of surd 3 plus 2. Okay, so surd 3 minus 2 is a conjugate of surd 3 plus 2. Okay, so from here we can conclude that conjugate, so this is called conjugate. So in general form, conjugate of surd A plus surd B is surd A minus surd B. Okay, surd A minus surd B, and vice versa. What I mean by vice versa is conjugate of surd A minus surd B is surd A plus surd B. So both of them are conjugate for each other. Okay, so when we know the concept of conjugate, now we can talk about rationalizing denominator. Rationalizing denominator. Okay, so for this one I will take only example. I will take example again. So example, simplify okay, set 5 minus 3 plus 3 over set 5 minus 2. Okay, so how we can simplify this fraction, this ratio? Okay, by usual, okay, I think when we in secondary school we already encountered conjugate, but we don't understand what is conjugate. Okay, so now when we understand the conjugate, okay, when we have if a fraction has a surd, okay, has at least, okay, has surd in the denominator here. When we call denominator, it is here, denominator. Okay, so when a fraction contains a surd in the denominator, okay, we can get rid the surd by rationalizing the denominator using conjugate. Okay, so what we can do here is, okay, so surd 5 plus 3 over surd 5 minus 2. Okay, so how to rationalizing the denominator now is using the conjugate. Okay, so since we have in the denominator we have surd 5 plus 2, so we are using the conjugate. It's conjugate, which is plus. Okay, so take note here, actually this one is multiply being 1, okay, first, and then since it is 1, we can express 1 in terms of fraction of the conjugate. So we rewrite it again as surd 5 plus 3 over surd 5 minus 2. Okay, so now 1 can be rewritten as, in terms of fraction using the conjugate, is surd 5 plus 2 over surd 5 plus 2. Okay, then we evaluate. So denominator we multiply with the denominator multiplied with the denominator. Okay, so we have here is, because both of them are plus. Okay, so what we can do is, okay, 25, sorry, it's not 25, actually 5 plus 5 surd 5 plus 6. Okay, and then denominator 1 is, okay, multiply this one is 5 again, and then surd 5 multiply 2, and then negative 2 multiply negative surd, so equal cancel out, so no need surd anymore. What's left is negative 2 and plus 2, so negative 4. So 5 minus 4 is 1. 5 minus 4, so now denominator is 1, so we don't need to write denominator anymore. So what's left is we evaluate the denominator. So our answer is 11 plus, sorry, okay, 5 surd 5. Okay, so this is what we meant by rationalizing the denominator, which is we talk about fraction that contains surd in the denominator. Okay, so rationalizing the denominator concerns about fraction that has surd in the denominator. Fraction that has surd in the denominator. Okay, so to rationalize the denominator, we are using the conjugate of the denominator. Okay, so that's what we meant by rationalizing the denominator. Okay. Okay, so last example. So we have last example. Okay, so last example is find the square roots of 7 plus 2 set 10. So we have this example. Find the square root of 7 plus 2 set 10. Okay, so to answer this question, we begin with let square root of 7 plus 2 set 10 is equals to set x plus set y. So we begin with like this step. Okay, so let square root of 7 plus 2 set 10 is equals to set x plus set y. Okay, so now we eliminate the first set here, the big set here. So how to eliminate? We put the power on both sides with half, to the power of half. Okay, we raise the power of both sides with to the power of half. So what we do here is is it half? Yes. No, it's squared. We put squared. So here also squared. Okay, squared. Okay, so square of the set is this one, 7 plus 2 set 10. Okay, but the right hand side is in bracket set x plus set y close bracket squared. Okay, so now we expand the right hand side. So what we have here is 7 plus 2 set 10 is x plus 2 set xy, okay, plus y. Okay, so here I'm skipping, I skip some step here. I don't know how many step here for you, but I really skipping some step here. Okay, so you can try it, you can figure out what is the step that I left out here, okay, to get this one. Okay, so now when we have here, okay, so now okay, so I think better I rearrange here. So 7 plus 2 set 10 is now x plus y plus 2 set xy. Okay, now what we can do is comparing the terms of the right hand side and the left hand side. So we compare the terms of the left hand side and the right hand side. So when we compare, we can say that 7 is equals to x plus y and square root of 10. I think we can evaluate this. Okay, 10 is x multiply y. Okay, so now here the problem of finding the square root of this number now has transformed into solving the two equations simultaneously, non-linear, because we have here non-linear, x multiply y. Okay, so I think I show here. Okay, so let x is 7 minus y. So we substitute this x into here, so we have 10. Instead of x, we can replace with 7 minus y multiply y. So we have here 10 is 7y minus y squared. Oh shit. Sorry. Okay. Okay. So we have this one. Okay, y squared minus 7y plus 10 equals to 0. Okay. 7. Okay, that's the problem with 7 here. Okay, that's the problem with 7 here. Okay. Okay. 7y. Okay. Yeah, you can use the calculator, but now I feel lazy to bring out the calculator. Or should I bring out the calculator? Yeah, I think I should bring out the calculator. Okay. Okay. So we have here is, so I think I use the mode, the solving equation mode here. Okay, so we have sorry, supposed to be mode this one. So we have 1. Astaghfirullahaladzim. Okay, we have 1, negative 7, and then plus 10. Is it correct? Okay, yes, plus 10. Yes, plus 10. Okay. Okay, so we have our answer now is the first y is 2, the second y is 5. Okay. So when we have these two numbers, so for first y, when y is equals to 2, x is 7 minus 2 equals to 5. And then when y equals to 5, x is 7 minus 5, which is 2. Okay, so now we have our answer. So we have our answer. X equals to 2, y equals to 5, and x equals to 5, y equals to 2. Okay, therefore, going back to what we assume here, going back to the first line here, so square root of 7 plus 2 sub 10 is set 2 plus set 5. That's all. Okay, because actually if you see here, when x is 2, y is 5, and when x is 5, y must be 2. It cannot be other value. Okay, so when you change the value, you will get the counterpart of it. Okay, so that's why I just left 2 plus 5, because 2 plus 5, set 2 plus set 5 and set 5 plus 2 are same. Okay, so this is our final answer. Alright, so that's all for today. I hope you understand what I have explained here with my broken English. I'm sorry. Okay, so if you have any question or if you have any comments, please please leave it in the comment section. Okay, so that's all for today. See you in the next video, inshallah. Assalamualaikum warahmatullahi, and see you.